Imagine holding a skull in your hands that doesn't quite look human. Its features are broad, its jaw powerful, its structure unfamiliar. It's not Neanderthal, and it's not Homo sapiens. Instead, it belongs to a mysterious species that left only whispers in our DNA, the Denisovans. For years, they've been a ghost in our evolutionary story, known only from fragments. But what if a complete Denisovan skull finally came to light? How would it reshape everything we thought we knew about human evolution? For most of human history, the Denisovans were invisible, not just forgotten, but completely unknown. Unlike the Neanderthals, who left behind dozens of skeletons across Europe, the Denisovans seemed like ghosts. Their entire identity rested on a few fragments: a pinky bone, a handful of teeth, and traces of DNA pulled from the soils of Denisova cave in Siberia. Imagine that, an entire species of human, reconstructed not from a full skeleton, but from microscopic clues hidden in the dirt. What little we knew already made them extraordinary. Their DNA revealed a species closely related to Neanderthals, yet distinct. They weren't just a side branch of evolution. They were travelers, survivors, and contributors to our own genetic makeup. Modern populations in Tibet, Papua New Guinea, and parts of Southeast Asia still carry Denisovan genes, evidence of ancient encounters that shaped who we are today. But without a face, without a skull, the Denisovans were always more mystery than reality. Scientists could only speculate. Were they robust and stocky like Neanderthals, or slender like early Homo sapiens? Did they look frighteningly different, or surprisingly familiar? That's why the discovery of a Denisovan skull feels like something out of science fiction. For decades, paleoanthropologists dreamed of this, the chance to look directly into the eyes of a species we barely knew existed. And now, against all odds, that dream has come true. The Denisovans are no longer just shadows in our DNA. They are flesh and bone. The discovery itself began quietly, as so many world-changing finds often do. Deep in the windswept highlands of Tibet, researchers were combing through a limestone cave system known as Baishia Karst Cave. This site had already hinted at secrets: fragments of tools, animal bones, even a fossilized jawbone that carried Denisovan DNA. But in 2023, something far more remarkable emerged from the sediment: pieces of a cranium, weathered by time yet undeniably human. At first glance, the fragments didn't look like much. Just splinters of bone, fragile and incomplete. But when pieced together, they revealed the contours of a skull, broad, with heavy brow ridges, thick cranial walls, and features that didn't neatly fit Neanderthals or Homo sapiens. This was something else entirely. Something we had been waiting for. The real confirmation came not from the shape, but from the genetics. Ancient DNA extracted from within the fossil matched Denisovan sequences perfectly. For the first time in history, we weren't just looking at a genetic trace, but the actual face of a Denisovan. The implications were staggering. Here was a being that lived nearly 160,000 years ago, high in the Tibetan plateau, an environment where oxygen is thin and survival is brutal. And yet, Denisovans thrived here, long before Homo sapiens even thought of venturing into such extremes. Scientists stared at the skull with awe. For decades, they had described Denisovans as phantoms of prehistory. But now, the phantom had a face. The lost cousin of humanity was no longer invisible. They had been pulled from the shadows of time, demanding that we rethink the story of our species. Once the skull was reconstructed, it began to speak, not in words, but in bone, shape, and structure. Its thickness suggested a people built for endurance, with skulls that could withstand harsh climates and demanding lifestyles. The brow ridges were heavy, more pronounced than in modern humans, giving the Denisovan face a striking, almost intimidating appearance. Yet, there were subtle similarities too, enough to remind us that these weren't distant aliens, but close cousins who shared much of our genetic makeup. The skull size hinted at a large brain, comparable to both Homo sapiens and Neanderthals. But what truly fascinated researchers was the environment it came from. Denisovans had adapted to the thin air of the Tibetan plateau, a feat so extraordinary that even today, only populations like Tibetans and Sherpas can survive long-term at those altitudes. Genetic studies later revealed something astonishing. Modern Tibetans carry a Denisovan gene that helps their blood process oxygen more efficiently. In other words, Denisovans passed down survival tools that remain alive in us today. The skull also reinforced an unsettling truth. Denisovans weren't some isolated tribe clinging to existence. They were explorers, innovators, and survivors who spread across vast landscapes, from Siberia to Southeast Asia, leaving their mark in DNA and archaeology alike. Holding the skull was like holding a mirror to a forgotten chapter of humanity, a reminder that our story is not linear, but braided. Modern humans are not the lone heroes of evolution, but part of a tangled web of relatives who lived, struggled, and thrived alongside us. And for the first time, the Denisovans weren't just a whisper of ancient genetics. They had a face, a place, and a legacy carved into human history. When most people imagine human expansion, they picture modern Homo sapiens spreading out of Africa in great waves. But what if Denisovans had been doing something similar, tens of thousands of years earlier? That's the question the fossil evidence and genetic studies are now forcing us to ask. From the icy mountains of Siberia to the tropical forests of Southeast Asia, traces of Denisovan DNA have been discovered in modern populations. This isn't just a sign that Denisovans survived in one remote cave, it's evidence that they thrived across diverse, unforgiving landscapes. Their genetic fingerprints show up most strongly in indigenous peoples of Papua New Guinea, Australia, and the Philippines. That means Denisovans, or groups closely related to them, must have made epic journeys across thousands of miles. But how? These weren't humans with ships, maps, or compasses. They had stone tools, fire, and an instinct for survival. Yet, somehow, they crossed mountains, rivers, and perhaps even seas, spreading their genes into future generations. Imagine them trekking through dense forests, climbing snowy peaks, or carving paths across open grasslands, survival written into every step. What makes this more astonishing is that their expansion wasn't a single event. Genetic diversity suggests that Denisovans separated into different branches, adapting uniquely to the environments they settled in. Some became masters of high-altitude life in Tibet, while others adapted to tropical lowlands. Each group carried pieces of the Denisovan legacy forward. It's almost as if Denisovans were quietly rewriting the human map long before Homo sapiens made their mark. Their presence hints at a forgotten wave of migration, one that complicates everything we thought we knew about who the true pioneers of human history were. Human history has never been a straight line. It's a web of encounters, interactions, and exchanges. The Denisovans prove this more than almost any other ancient species. When geneticists began analyzing DNA from Denisovan fossils, they stumbled onto something astonishing: signs of interbreeding with both Neanderthals and early Homo sapiens. This means the Denisovans weren't living in total isolation. They were meeting, mixing, and shaping the future of humanity in ways we're still uncovering today. Think about that for a moment. Imagine a Denisovan band traveling through the rugged valleys of Central Asia, only to stumble upon a Neanderthal clan. Did they fight, trade, form alliances? Whatever happened, it wasn't just confrontation, it was connection. Their shared genes prove that these encounters were deeply intimate. In fact, Denisovans and Neanderthals appear to have been more than just neighbors. Some evidence suggests entire populations intermingled, creating hybrid communities that blurred the lines between species. And when Homo sapiens entered the picture tens of thousands of years later, the same pattern repeated. The most remarkable part? Many of us still carry these Denisovan traces today. If you've ever wondered why some populations thrive at extreme altitudes or why certain genetic adaptations exist in specific regions, Denisovans may be the hidden reason. Their survival skills weren't just their own, they were passed down through bloodlines, shaping us even now. These crossroads of contact remind us that human evolution isn't a story of separate species staying in their own lanes. It's a story of overlapping lives, unexpected connections, and a shared struggle for survival. And the Denisovans weren't just participants, they were key players in that drama. One of the most astonishing revelations about the Denisovans is their ability to thrive in some of the harshest environments on Earth. Unlike many human species who struggled when conditions changed, Denisovans adapted, and those adaptations still live within us today. Take the Tibetan Plateau, for example. At altitudes where the air is thin and survival is nearly impossible without modern gear, Denisovan genes gave later human populations the ability to thrive. Today, many Tibetans carry a unique genetic variant traced back to Denisovans, a gift from interbreeding that helps regulate oxygen use in the body. Without this adaptation, large-scale human settlement in such extreme conditions might never have been possible. But altitude was just one of their tests. The regions Denisovans roamed were wild frontiers, icy tundras, dense forests, windswept steppes. They weren't simply enduring these landscapes, they were making them home. Their tool-making skills, hunting strategies, and physical resilience suggest a species that was not fragile but remarkably resourceful. This adaptability speaks volumes about who they were. Far from being a mysterious footnote in human history, Denisovans were innovators in their own right. They may not have built monuments or left behind cave art, but their legacy is written in survival itself, in the genes and resilience that humanity still carries. So, when we think of Denisovans, we shouldn't imagine shadows lost to time. We should picture pioneers who looked at impossible landscapes and said, "We can live here." And in doing so, they laid the groundwork for our species to conquer environments that would otherwise have remained forever closed. Imagine standing deep inside a cave, lantern light flickering against damp stone walls, when a fragile fragment of skull emerges from the earth. It's not just any bone, it's a piece of a face, a brow ridge, a curve of jaw, belonging to a Denisovan, one of humanity's most elusive relatives. For decades, Denisovans were ghosts in our story, known only through scraps of DNA pulled from a finger bone and a few teeth. But then, this partial skull changed everything. For the first time, scientists weren't just piecing together genetic code, they were staring at the physical remains of a being that had once walked the earth. The skull, discovered in Siberia's Denisova cave and later complemented by finds in Tibet, gave us a glimpse of what Denisovans may have looked like: strong, robust, with a wide skull built for endurance in cold, unforgiving climates. This wasn't just a fossil. It was a mirror into a forgotten past. Proof that Denisovans weren't some fleeting experiment of evolution but a powerful branch of humanity in their own right. Their remains told us they weren't frail or marginal. They were survivors, explorers, and in many ways, equals to Neanderthals and even to us. And here's the twist: as scientists studied this skull, they realized it carried features seen in other mysterious fossils scattered across Asia. Suddenly, fragments long thought to belong to unrelated species began to make sense. They weren't outliers, they might have been Denisovans all along. With this single skull, the shadowy outlines of the Denisovans sharpened into focus. The question was no longer if they mattered in our story, but just how much of our world was shaped by their presence. The Denisovan skull was more than a fossilized relic. It was a key to unlocking secrets hidden inside our very DNA. Because while Denisovans may have vanished as a distinct group, their legacy lives on inside us. Genetic studies reveal something astonishing. Millions of people today carry Denisovan DNA. If you're of Asian, Oceanian, or indigenous Australian descent, you might have inherited anywhere from 3 to 6% of your genome from them. That may not sound like much, but these tiny fragments shaped survival itself. Take high-altitude adaptation, for instance. In Tibet, people thrive in oxygen-thin air thanks to a gene variant called EPAS1, a direct gift from Denisovans. Without this genetic inheritance, entire populations might never have survived the harsh, towering Himalayan plateaus. This wasn't just a trace of ancient contact, it was Denisovan resilience, living on in modern bloodlines. But their genetic fingerprints don't stop there. Research suggests Denisovan DNA also contributes to our immune systems, making us more resistant to certain diseases. In other words, their survival strategies, honed over millennia of life in unforgiving environments, became ours. Think about that for a moment. A species that disappeared tens of thousands of years ago continues to protect, strengthen, and shape us today. We are, in a very real sense, part Denisovan. The skull reminded us of their physical presence, but our DNA revealed their invisible hand guiding our evolution. They weren't just neighbors we briefly encountered, they became part of who we are. And yet, this raises a deeper mystery. If Denisovans influenced us so profoundly, what else might their bones and DNA reveal about the paths humanity could have taken? The Denisovan skull did more than fill a gap in the fossil record. It challenged us to rethink what it means to be human. For centuries, we drew hard lines. Homo sapiens were us, and everything else was other. But discoveries like this blur those boundaries. Were Denisovans really so different? Or were they simply another branch of humanity, with hopes, fears, and struggles much like our own? The more we learn, the more the story of human evolution looks less like a straight ladder and more like a tangled web. Neanderthals, Denisovans, and early Homo sapiens weren't isolated species existing in parallel. They met, mingled, and left their marks on each other. Our evolution wasn't about replacing others, but absorbing and blending with them. The Denisovan skull forces us to confront this truth head-on. Its structure shows a face both familiar and foreign, strong jaws, thick brow ridges, but also hints of traits we'd recognize today. Looking at it, we see not a stranger, but a relative we've forgotten. And that's the real power of this discovery. It collapses the walls between us and them. It reveals that being human isn't about belonging to one pure lineage. It's about connection, adaptability, and survival through unity. Perhaps the skull is more than a fossil. Perhaps it's a mirror, reminding us that our humanity has always been shared. That the strength of our species lies not in separation, but in integration. So the question remains, if our ancestors once thrived by embracing connection with others, what might we achieve today if we remembered that lesson? The lost Denisovan skull isn't just a fossil, it's a message from deep time. It tells us that our story has never been simple or linear. Humanity was forged not through isolation, but through connection. Different groups meeting, mixing, and leaving traces that still live on in us today. Every discovery like this doesn't just rewrite textbooks, it reshapes how we see ourselves. If survival and progress were once built on unity, adaptability, and shared strength, maybe the same is true for us now. So, if the Denisovans could leave their mark on us across hundreds of thousands of years, what mark will we choose to leave on the future?